Hello everyone. Over the past couple weeks I've been using the 440 a little bit here and there to make a couple projects that are for some upcoming videos, and in the process I noticed there's a couple little tweaks and a couple little mods that I wanted to do to mainly the enclosure, so I'm going to go over those in this video. The first one is getting some light inside this enclosure. I started with a 5-meter long strip of these LEDs. These particular ones I got from Amazon. They're waterproof, and the nice thing about these strips is you can just use a normal pair of scissors to just cut them to length. So I cut all my lengths that I needed inside the cabinet. These particular ones are waterproof, and they use a 5630 LED, which is a little bit brighter than the 5050 LED. And I also got these little T connectors that I'll show you a little bit later. Since these are waterproof, they have this little silicone covering over top of them to keep water out. And it was a little tricky to figure out how to access the little pads there to connect the connectors. I just used a knife and kind of scored it and then kind of sliced it away. And then you can kind of peel that coating away. It actually peels away really cleanly from the strip. These connectors were really nice because there's no soldering required. You just kind of like popped open that little hatch, pressed them in, snapped it closed, and it made for a really clean connection. From here, it's just as simple as peeling back the adhesive on the back and kind of positioning them inside the enclosure. Initially, I was going to kind of do it, all at once, connect everything up outside the enclosure and then put it in, but I just kind of decided to go strip by strip. And so really I just kind of held the strip out, held my finger where I think I should cut it, brought it back to the bench, chopped it off with the scissors, and then put it inside the connector, and then peeled the strip off, and then put it against the enclosure. So it really couldn't have been much easier. And this stuff really is very sticky, so I don't anticipate it falling off anytime soon. Last thing I had to do was just go ahead and test it. Looks great. I used a total of 5 LED strips inside the enclosure. I've got 1, 2, 3, 4, and 5. The power starts over there in the back corner, and it just has a barrel jack at the end, so it connects into this little remote control dimmer module, and then from there it connects to a power supply. In the description of this video, I'll show you all the Amazon links so you can kind of get a better idea of how it works, but power comes in through the wall, goes into the power supply, goes in through the little module that connects to the remote control, into the first strip, over here, into the T connector, down this way, over this way, into another T connector that goes down, and then back, and it just kind of dead ends in the back. I only ended up using about half of the full LED strip that I got from Amazon, so I have the rest of that for another project, or I was thinking about maybe wrapping it around and coming back and doing like another circuit across the top. I could do that as well if I wanted, but right now I'm sitting at about 3,200 lumens inside here, which is about equivalent to a shop light inside of here, and it is more brightness than I'm going to ever need, so I don't think I'm going to go back and add any more light. I mean, there's just a ton of light coming off of this thing. And with the remote control, I can turn it on, I can turn it off, I can do dimming, and I can even set any of these crazy modes like strobe, so it's kind of interesting. More on that in later videos, so be sure to check back. I have a couple interesting plans for that. But as far as the enclosure goes, I really, really like having the lights in here. This was a fantastic little mod to do. While installing the LED strip lights, I wanted a better way to hold up the windows, so I came up with these little magnetic window holders that would do exactly that, and they're really simple to make. I started with these little cup magnets that I found on eBay. The only problem was the one small enough had a number 6 thread inside of it, and I needed that to be for a number 8 screw, because that's the knob that I had. So I just used a pair of pliers and a drill and drilled it out a little bit bigger. This really wasn't that big of a deal. I didn't need to drill it out that much so the magnet didn't crack. They were just pretty hard, so it took a little bit of drilling. Once I got that done, I got my knob, I got my stainless steel screw, a lock washer, and the magnet. I ended up using that lock washer because on the back of the magnet there's a little bit of a countersink, and so the head of the screw would sit too far in, so I needed to kind of move it out a little bit. So I just kind of put all that together, screwed on the knob, tightened it up, and that's all there is to it. I ended up making 2 of these, and because they're magnetic, they can just sit on the enclosure like that. I also can keep them down at the base. The other kind of interesting little thing about them is that if you take one and you just kind of put it in the slot, makes opening the doors one-handed really easy, and then you can just pop it out. So they're pretty cool. Call me crazy or maybe just a little bit lazy, but I didn't like having to reach all the way down into the stand, open up the door, press the on button, then close it, and then when I'm done, go ahead and do that whole same process to turn off the computer. So I wanted an external or remote power switch for the computer, and why not? Let's add an indicator light so I can see if it's on. First thing I had to do was to, of course, unplug the computer, rip it out from the stand, and start hacking it open. If you've ever built a computer before, you know that in the corner of the motherboard somewhere, there's usually this row of headers, and that is where all the buttons and LEDs for the front panel of the computer plug into. So once I cracked open the case, it was just a matter of locating those and figuring out which pins were for the power LED and which pins were for the power switch. And I just needed to remotely locate those. To make life easy on myself, I used a 3.5mm audio connector for the computer and the e-stop. So I have my computer over here, let's say, and then here is the e-stop button, the start and stop button. So I have a 3.5mm audio jack here, 3.5mm audio jack there, and then I have just a headphone extension cable. I wanted this to be really simple so that the parts were easy and I didn't want to have any proprietary connectors. But at the same time, I wanted to be able to unplug everything really easy. I didn't want everything hardwired or wires hanging out, so I made it nice and clean. So on here, on the back on one of the expansion ports, I just drilled a hole through the expansion port and put a 3.5mm audio jack there, so you can just use a standard headphone extension cable on the back of the PathPilot controller. And over here, I did the same kind of thing. I have a 3.5mm jack on the back of the e-stop switch, and then I have a button and an LED inside this enclosure, and I just went ahead and drilled some new holes for that. And then both of them, you can just unplug the cable if you need to move or reconfigure the machine, whatever. Once I determined what pins I needed to use on the motherboard, I need to make these little Y connectors. I still wanted to maintain functionality on the power switch and the LED, so I need a cable that would connect into the motherboard. One side would split off and connect into my 3.5mm audio jack, and the other side would split off into a female connector that I could plug the original cables into. So then this went off into the little ribbon cable on the front portion of the computer, the existing connection, and then this one went into the back of the computer for the 3.5mm audio jack. So once I got those little Y cables made up, then I took and wired everything up to the 3.5mm audio jack on the back of it, and then got the computer side of it done. From there, it was just a matter of fitting the button and the LED inside. I use these little quick disconnect Molex connectors on the inside so that if I ever needed to remove the face of the e-stop cover, I could just quickly disconnect those. So that made wiring a little bit easier. And then just a matter of screwing everything together and testing it out. Here is the new modified e-stop box. We've got the LED and we've got the on-off button over here. I decided to put the on-off button up against the side of the enclosure so it's a little bit harder to get to. The same rules apply for the button as they would on the front of it. When the computer is fully booted up, you still need to hold it down for like 30 seconds to turn off the computer, so you're not going to just accidentally bump against this button and turn off the computer mid-program. You have to hold it on for quite some time. And so simply pressing it turns on the computer, and since it's not booted yet, I can just press it to turn it off. And you can see the jack coming out of the back here, and I just have the cable kind of run along the bottom, runs to the back of the stand and inside into the computer bay. So it's really clean. You can't even really tell that there is anything different about this. And now I can turn the computer on and off from the front, right where the e-stop is. That's about it for this video. These were just a couple of mods I did right out of the gate because like the lighting, they were kind of necessary and it just made sense to do right now. Of course, they're not absolutely necessary to do, but they just make using the machine a little bit easier. As you can see, I have been making quite a bit of chips with this machine for some upcoming projects in the next couple of videos. Stay tuned for those. I'm still kind of working out the final kinks on everything, but I definitely will have something to show next couple weeks, so see you then.